This video will demonstrate all the aspects and functionality of the SIDSynth. Each control will be demonstrated in detail with audio examples. The control panel consists of 4 sections. The 3 SID channels highlighted by a red, green and blue Space Invaders sprite, and the lower section contains the LFO and envelope sections and additional system global controls. Each SID channel provides a physical user interface for all the functionality of the SID chip. Also included is additional functionality and capabilities. Each SID channel contains common controls with only the fine-tune and gate delay functions emitted from SID channel 1. The video will use SID channel 2 to highlight all the control functionality. Each SID channel contains 4 waveforms: triangle, sawtooth, pulse and noise. There are 8 options containing single waveforms and combinations of. Noise can only be used on its own. The pulse width control is only active when the pulse waveform is selected. Above the waveform selection LEDs is a gate indicator, illuminating with every key press to show the channel is active. To turn off a SID channel, the waveform selection dial should be rotated fully anti-clockwise. The waveform section also includes an LCD display on each SID channel. The LCD display shows control parameters for transpose, fine-tune, ADSR and the glide ramp sections. Parameter pages change automatically when a control is moved or by pressing the menu button that is also the gate indicator on SID channel 1. The modulation section is typical of most synthesizers. It includes transpose on each of the SID channels, fine-tune on SID channels 2 and 3, and an octave shift on all channels. The filter section comprises of a frequency cutoff control, a resonance control, buttons to select high pass, band pass and low pass or any combinations of the 3, and a velocity tracking option. The filter is engaged by pressing any of the 3 band buttons. By turning the frequency cutoff dial, this opens and closes the filter. The resonance control adds a small boost at the frequency of cutoff. The velocity track button allows the frequency cutoff to be controlled by the velocity of the keys pressed on the keyboard. This frequency cutoff articulation can be used to add dynamics to a performance. The ADSR section contains the controls to change the amplitude envelope. These are attack, decay, sustain and release. Each control's parameters are displayed on the LCD screen. It should be noted that on the SID chip these are stepped controls. By adjusting the controls, different sound timbres can be created instantly, from percussion sounds to pads. The glide ramp section is used to manipulate pitch either between notes played on the keyboard or as a single one-shot sound. This section can create some extremely creative sound effects for use in video game sound design and allow expressive articulation in live performance. Press the glide ramp on-off button to switch the function on. When the mode switch is in its upright position, this is in glide mode or portamento. This is also highlighted in the LCD display when switched. When the mode is set to portamento in the display, the notes played on the keyboard will glide smoothly between each other. The duration in which the pitch rises and falls is governed by the speed control. By engaging the smooth coarse button, the pitch characteristics will change from a smooth rise or fall in pitch to a chromatic scale. When the legato feature is engaged in glide mode, this allows expressive articulation of the glide function, only applying the pitch shifting when the keys being played are overlapped. This function provides a dynamic and expressive performance effect. By changing the mode switch to ramp, the pitch characteristics now ramp up or ramp down from a single key press. The direction and note range is governed by the range control. Again, the duration of the pitch bend is controlled by the speed dial. The smooth coarse function can also be used. The ring modulation and odd sync controls had limited use in video games, as the function required 2 out of the 3 SID channels, due to the function using a carrier and a modulator. Ring modulation can produce metallic bell-like sounds. Ring modulation only works with a triangle waveform, so it is automatically selected when the ring modulation button is engaged. The frequency control adjusts the modulation frequency. Hard sync is where one oscillator resets the other. Hard sync can create some interesting effects when combined with the glide ramp function. The volume controls on the SIDSynth only work with an original SID chip installed in each of the SID cores. They have no other function but to mute the swing SID chips. On SID channels 2 and 3 is a gate delay. This delays the on and off messages to the channel. It can be used creatively to produce a pseudo delay effect. The first controls in the lower section of the control panel are global system controls. Mod wheeled mode switch governs the incoming mod wheel MIDI data to control pulse width, the filter cutoff, or can be used for the LFO depth. The pitch bend range buttons adjust the pitch bend range in semitones. The range is a semitone to a full octave. The 6 buttons to the right of the global system controls assign the desired SID channel to the LFO or envelope sections. To the far right of the lower panel are the LFO and envelope destination controls. The LFO destination control can send a signal to manipulate pitch, pulse width or filter cutoff. The envelope can manipulate pulse width and filter only. The LFO contains 6 waveforms: sine wave, sawtooth, inverted sawtooth, triangle, pulse, and a random generator. The LFO frequency has a range from 1 Hz to 24 Hz. When the normal slow button is pressed, this divides the frequency by 10, creating extremely slow LFO sweeps. The fade speed governs the speed in which the LFO depth reaches its maximum. Fade delay governs how long the duration is before the fade starts. Both controls cover a range of 0 to 12 seconds. The phase dial controls where the LFO waveform starts throughout its cycle. The offset control shifts the LFO depth in relation to the start frequency. Low ramps up to the target frequency. Centre crosses the target frequency. And high ramps away from the target frequency. The envelope consists of 5 controls. There is attack amount, decay amount and sustain amount. Then there is attack delay and decay delay to govern how long it takes for the attack and delay amounts to reach their set position. The release time of the envelope is governed by the release control found in the ADSR section of each SID channel.